All right, in this video, we're going to talk about a little bit about nuclear decay equations. So a nuclear decay equation shows what happens when a nucleus, usually an unstable, radioactive, isotopic nucleus, releases a particle. And that particle is a product of that particular decay equation. And so you get from one nucleus a radioactive particle plus an additional new nucleus formed. There are three different types of decay particles that we're going to discuss. So the first one is an alpha particle. An alpha particle is represented by a nucleus that has a number or a mass of 4 and a Z number of protons of 2. And the symbol, the alpha symbol, looks like a little fish. This could also be written as a helium nucleus, because if you look at the periodic table, helium has an A of 4, a Z of 2. So the notation of 4/2 alpha or 4/2 He are used interchangeably. You'll see me most often use the 4/2 alpha just because it's a little bit faster. Okay. The second one is a beta decay particle. So beta decay particle, 0/-1 beta. So that means that we have a mass of 0 and a charge of -1. So this one doesn't have any protons. What it actually has is an electron. And because electrons have no charge, no mass, the symbol 0/-1 little electron or 0/-1 little e is often used interchangeably with the beta. I most often will use the beta just because sometimes the little e tends to look like the A, and you do want to kind of avoid any sort of ambiguity. The last one I will mention, though we don't calculate with it, is gamma, a gamma particle. Gamma particles have no mass, no charge, and are represented by the Greek letter gamma, which looks like a Y. Because we can't really do any math with this, we don't calculate with it. So we mention it, we talk about it. Gamma particles are really strong. They can penetrate lead, but no math. So we kind of just let that one go. So we're going to look at 2 examples of calculating and writing equations for alpha decay, 2 examples for writing equations with beta decay. This particular topic is something that's really, really easy. And what I find is that students do really well with it. And then because it's so easy, you kind of brain dump it. And then when it comes up again, you get into trouble because you kind of forget where things go and how to write it with the proper format. So kind of make sure you keep track of those sort of important details as we go through this. To write nuclear decay equations, the only thing you really need is your reference packet. Okay. All right, and here's your big reminder note. Remember that the particle being produced, so either the alpha or the beta, and again, we're going to kind of forego talking about the gamma since we can't do any math with it, is being produced, is being made. Therefore, it is a product of the reaction and thus goes on the right-hand side of the arrow. Okay? So, first one, write an equation for the alpha decay of Curium-235. So the first thing that you see here is it's telling you we're doing alpha decay. So 4/2, the little fish is going to be involved. And it tells me that the particle I'm starting with is an isotope of curium. So the only thing that I'm really missing here is I need to go find curium, and I need to figure out how many protons it has. So curium. A lot of times people will confuse cesium, which is 55, with curium, which is 96. Make sure you really read carefully the names of these elements. So curium has a Z number of 96. That means it has 96 protons. So this is giving me my A number. That's going to go on top. So 253/96 cm is my symbol. Okay, that is my only reactant, my only starting particle. Then I'm going to decay, and I'm going to produce what? Well, I already know. I'm making an alpha particle. 4/2 the fish plus, really, I just need to figure out what goes in this missing piece. So just like any other mathematical equation, right? If you think about this arrow like it's an equal sign, but don't write an equal sign, it's for sure an arrow. But if you think about it like an equal sign, right, all the numbers have to be equal. So I have 253 and 96 on this side. I have 4 and 2 on this side. I need to know what I have to add here so that the sum of the particles here equals this. All right, so what plus 4 will give me 253? All right, well, 249. All right, so 249. What plus 2 will give me 96? All right, 94. All right, now 94, that's a Z number. What element has 94 protons? Right there. Plutonium, Pu. That's it. That's all we're doing. The only thing you got to really watch is this is asking me to write an equation. This whole thing is an equation. Writing 249 over 94 Pu is not an equation. That's just a particle. I need to have the original curium, 253 over 96 cm. I've got to have an arrow that tells me a reaction's taking place. I got to have my particle that's being formed. I need to have a plus sign, right? If I'm writing an equation, these are my punctuation points, right? Just like with a sentence. You're not going to write a sentence without a capital at the beginning and a period at the end. Don't forget your arrow and your plus sign. If you leave these things out, unfortunately, it's wrong. So you need to make sure you watch your details. And then what am I making? 249 over 94 Pu. All of that together is the correct answer. If any part of it is wrong, it's wrong. Okay, so mind the details. Watch what you're doing. Just like when we did our Zappin charts, do not put fraction bars in between these guys. A over Z, nothing in between. All right, and let's do another one. Alpha decay of protactinium 245. So again, alpha, I know what I'm making, 4 over 2 fish. Protactinium 245, I'm starting with an isotope of protactinium. I've got to go to my periodic table and find it. Plutonium, neptunium, uranium, protactinium. Protactinium is 91. So 245 over 91, Pa, arrow, what am I making? An alpha particle, 4 over 2 fish, alpha, plus what? Oh, what's my missing part? Got to make the math work. 245, and I've got 4. So what do I have to add to 4 to get 245? 241. 91, I've got 2. What do I have to add to 2 to get 91? 89. Look at the periodic table. What element has 89 protons? AC. Okay, easy enough. All right, arrow, plus sign. Now, it doesn't matter if you have these two things reversed, as long as there's a plus sign in between them, right? You can write your plutonium before your 4 over 2 fish, but you need to make sure that they're both there. They're both represented, because if all I have is the plutonium, my math doesn't work. This doesn't add up. All right, now, write the equation for beta decay of erbium 175. So now we're talking beta, 0 over -1 beta. All right. Erbium 175. So let's go to the periodic table. Let's find erbium. Okay, right here. Erbium has 68 protons. So 175 over 68. My symbol for erbium is ER. Arrow. Okay. Beta. 0 over -1 beta. Plus. Now we got to figure out what goes in the missing spot. Well, top's easy, right? 175 and 0. What do I have to add to 0 to get 175? Still 175. Bottom's where you got to watch. This is negative, right? So what do I have to add to -1 to get 68? Can't be 67. 67 and -1 is going to give me 66. So I got to go up 1. 69 and -1 would give me 68. What element has 69 protons? Thulium, Tm. Last one. Write an equation for the beta decay. Again, beta, 0 over -1 beta. beta decay of samarium 146. So samarium, go to the periodic table, find it. Oh, 62 protons. So 146 over 62 Sm, arrow, beta particle, 0 over -1 beta, plus. All right, 146, 0, so 146. What do I have to add to -1 to get 62? Got to go up 1. 63 and -1 is 62, so 63. What element has 63 protons? Looking on the periodic table, Erbium, EU. All right, so really easy. Just a couple things, a couple details that you really need to make sure you watch and pay attention to. But nuclear decay equations, alpha beta decay equations, really, really easy. Okay, hope that helps.